For nearly 3 billion years, life on Earth followed a strict chemical routine. Across those ancient oceans and billions of generations, nothing had a brain. Early life was simple. Tiny, soft-bodied organisms drifted through the water, responding to the physical world through basic chemistry. If food bumped into them, they absorbed it. If they touched a toxic surface, they recoiled. They didn't hunt or navigate. They operated on automatic, localized reactions. Because there was no central processing, these organisms lacked any form of psychology. They couldn't feel fear or form a memory. They had no capacity to learn from the past or construct a plan for the future. This aquatic ecosystem was successful at keeping life going, but for all its vastness, it was essentially a planet filled with biological machines, functioning without any awareness that they existed. As competition increased, survival required organisms to grow. Bodies became larger, and creatures needed to move faster to find resources or avoid hazards. But size created a lethal engineering problem. Organisms relied on localized chemical signals, which took too long to travel. If a predator clamped on a tail, the warning impulse rippled too slowly. Before the signal reached motor functions to trigger escape, the animal was eaten. To support larger bodies, biology had to move beyond these sluggish local networks. Evolution needed a way to collect data from the extremities and transmit high-speed commands from a single hub. The first solution was specialized biological wiring. Organisms began developing nerve cells that formed fast, conductive pathways through their tissue. Over time, these scattered networks began to bundle together at the front of the organism, weaving into a dense, singular knot. We can see the blueprint of this in tiny, ancient predators like Hykuichthys, a creature swimming through the oceans hundreds of millions of years ago that possessed one of the earliest known vertebrate nervous systems. This cluster of nerves acted as an ultra-fast switchboard. It took raw data streaming in from basic eyes and touch sensors, instantly integrated it, and fired a coordinated, full-body command back out to the muscles. The original brain was strictly mechanical. It was an organic survival calculator, built to process data fast enough to keep the organism from dying. This predictive speed changed the math of survival. For the first time, an animal could stop reacting to the present moment and begin anticipating the immediate future. Imagine two creatures. A shadow passes over them. The organism relying on a decentralized nerve net receives the visual cue too slowly, and the predator strikes. The creature with a central brain processes the shadow instantly, computes the trajectory, and darts away before contact. Escaping death by a fraction of a second compounds. Over millions of years, the brained organism survived, multiplied, and outcompeted the slower biological machines around them. Around 541 million years ago, this computing advantage coincided with the Cambrian explosion. The oceans rapidly filled with an astonishing diversity of complex animals and new defensive traits. It triggered an intense biological arms race. A predator with a faster processor could calculate intercepts better, which meant prey had to evolve even faster processors for evasion. The slow equilibrium of ancient Earth was gone. The invention of rapid information processing turned the oceans into a lethal arena of strategy and competition. Once the central command hub was established, evolution built outward, adding new functional biological layers on top of the old ones over hundreds of millions of years. The core remained dedicated to base survival. Eventually, a secondary layer snapped into place, introducing the first memory. As animals evolved into mammals, the brain grew outward again, developing intricate structures to handle emotion, abstract thought, and social cooperation. These new traits provided concrete advantages. Fear taught an animal to avoid a specific valley. Curiosity drove it to find a richer food source. They could learn the patterns of their environment and adapt to them. These compounding layers allowed animals to do more than endure their environments. They could steer through the world, using memory and emotion to weigh choices before making them. As the brain grew capable of processing memory, emotion, and sensory data simultaneously, the line between an automatic reaction and a deliberate choice began to blur. Within this complex internal data stream, the first flicker of subjective awareness appeared. For billions of years, the cosmos was a theater of raw physics. Continents shifted, stars ignited and burned out, and oceans rose and fell in total silence, with nothing to observe it. Then, a biological entity looked back at it. The neural architecture that allows you to comprehend this very sentence is part of an unbroken evolutionary chain, tracing back to those tiny knots of nerve tissue inside ancient ocean-dwelling pioneers. Every piece of music composed, every scientific discovery recorded, and every fear felt is the direct output of that one biological innovation. Evolution designed the brain to keep organisms alive long enough to survive. Yet, in doing so, it created a mechanism that finally allowed the universe to understand itself.